Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 2.3, which is going to deal with rotations. Now, section 3 is the third installment of our transformations module. So far, we've talked about a translation and we've talked about reflection. Today, we are going to look at rotations. Now, today, we're going to look at rotating in the coordinate plane. And there's going to be very specific boundaries on what our rotations are, and that specifically is shown in our learning goal. So you will be able to draw the rotation, whether it's 90 degrees, 180, or 270, of a shape in the coordinate plane. So today you're going to be given a shape in the coordinate plane, and you're going to ask to either rotate it 90 degrees, 180, or 270, whether counterclockwise or clockwise in the coordinate plane. So, with that said, let's go ahead and jump into our rotation stuff for today. This section right here kind of just goes through and talks about rotations, results of rotations, and what happens. So we're going to rotate around a point. For our purposes in the coordinate plane, we're going to be rotating around the point 0, 0, or the origin. Now, if you were rotating outside of the coordinate plane, you would have a point you would rotate around. Today, we're going to look at the point that is the origin. All right, now every point and its image are the same distance from P, meaning whether the original point and now its new point are the same distance. Okay, so the shape that we rotate is going to be the same distance from the origin as it is in either the pre-image or the image. And then also angles that you can form using the original point and the prime point. When you form an angle, that will match the angle of rotation. All right, so for today, we do have more rules for rotations, and that's what we're going to take a look at first before example 1. So just like we have rules for translations where you add or subtract a number to x and then add or subtract a number to y, when we talked about section 2.2 with reflections, there was a list of 4 different ones where it was a reflection over the y-axis, x-axis, y equals x, and y equals negative x. Today we're going to have 4 different rules for 4 different rotations. 90 degrees, 180, 270, and 360. Again, this chart, this table is super helpful to have at the ready while you are doing these problems. Okay, I'm not expecting you to memorize these for the homework. Okay, I want you to know how to use them. Okay, so either again, write it on a piece of paper in your notes, or have the completed notes for this video up for reference so you can look at this table. Okay, I don't necessarily expect you to memorize these right now, just know how to use them. So, a 90-degree rotation counterclockwise is going to ask us to go x comma y to negative y comma x. So, what that means is you're going to flip x and y, and you're going to change the sign on the old y or the new x from positive to negative, negative to positive. For a 180-degree rotation, all you're going to do is take x comma y and change it to negative x comma negative y, meaning you're going to change the sign, positive to negative, negative to positive, on both x and y. 270-degree rotation counterclockwise goes from x comma y to y comma negative x. So you're going to flip x and y, and you're going to change the sign on the old x or the new y. Now, a 360-degree rotation just ends up back at its same spot, so we're not going to really worry about doing that. Don't worry about memorizing it. In fact, it's really never going to pop up in your questions. Now, understand this, a 180-degree rotation, whether I rotate clockwise or counterclockwise, I end up at the same spot. Same for 360. Now, in the problems today, if they ask you counterclockwise, you need to follow these rules. Okay? If they were to ask you clockwise, understand that a 90-degree rotation counterclockwise is the same thing as a 270-degree rotation clockwise. So the rule for 90 counterclockwise is the same thing for 270 clockwise. And then 270 counterclockwise equals the same thing as a 90-degree clockwise. If they do not tell you which way to rotate, they want you to rotate counterclockwise. Okay, it's just the way the book wants you to do it. It's just the way that they have it set up. Now, to kind of give you an example of what that looks like, if we look at part A, so I have my quadrilateral ABCD. Okay, I'm going to use parchment paper to help demonstrate this. So I've already gone through and traced and indicated where my origin is. If I am rotating counterclockwise, okay, think about the face of a clock. Clockwise, you're going to rotate this way across or throughout the coordinate plane. Counterclockwise, you're going to kind of go in a leftward direction in the coordinate plane. So if I want a 90-degree counterclockwise rotation, it means I'm going to rotate around the origin 90 degrees, and I end up there. Okay, so that's my 90 degrees counterclockwise rotation. 180 is going to end up there, and then a 270 ends up right there. Now, if we're talking 360, 360 just means we end up at the same point, back to there. But counterclockwise, you're going to kind of move in a leftward direction around, so that means I'm going to move in this direction. Okay, so it's 90, 180, 270. Okay, just like if we look at B, this would be 90, this is 180, 270, 360. Okay, so you kind of move left, like kind of up and around to form your counterclockwise. All right, so we're going to use these rules to help us. We don't really need to use parchment or patty paper or wax paper today. We're just going to follow the coordinate notation rules. So for quadrilateral ABCD, they want me to rotate this counterclockwise to 70. So a 270 counterclockwise rotation is y comma negative x. So we have y comma negative x. So that's going to be our starting point. Now, they don't tell me the points for A, B, C, and D, but they are in the coordinate plane. So we need to go through and identify those first. So point A is at 0, 2. B is going to be at 1, 4. C is at 4, 2. And D is going to be at 3, 1. So those are our original points. Now we need to go through and rotate these based off of our rule. So let's go through and do that now. So again, y comma negative x means we're going to flip x and y, and off of our old x we're going to change the sign, or our new y for this purpose. So we're going to have a prime, b prime, c prime, and d prime. And we're going to go through and rotate. So we're going to flip x and y. So my y is now x. So I'm going to go through and change those for all the points. So it's 2, 4, 2, 1. So all the y values are now x, and then all my x values are going to be y, except I have to change the sign. So 0, I can't have a negative 0, so it stays at 0. 1 goes to negative 1, 4 goes to negative 4, and 3 goes to negative 3. So that is my now rotated points. So we're just going to go through and draw those, or plot those. So we have 2, 0 for A prime. B prime is at 4, negative 1. C prime is going to be at 2, negative 4. And D prime is at 1, -3. So I now have my 4 points. Let's just go through and connect my vertices and create my shape. So that's kind of a rough drawing since I didn't use my ruler. But if I wanted to go through and double check, again, you don't have to do this. This is just to help you see it. So rotation 90 degrees, rotation 180, and then a rotation of 270 degrees counterclockwise. That lines up with the figure we just drew from our rotated points. Therefore, this is my rotation of 270 degrees. All right, so that is how you're going to run through example 1. You're going to take the points in your coordinate plane, go through and list them, see what they want you to rotate, find your rule in this table, change all the points, and then plot them anew. So I'm going to go through and practice B just to give you another example, and I will leave parts C and D for you to practice on your own. So let's take a look at B. So we have triangle KLM, and they want us to rotate 180 degrees. So let's first go through and identify our points K, L, and M. K is at 2, -1. L is going to be at 4, 1, or -1, sorry. And then M is going to be at 1, -4. All right, so those are my 3 points. Now they're going to ask me to rotate 180 degrees. Clockwise, counterclockwise, same thing. So it's going to be -x, -y. And that's how I'm going to go through and transform these points. -x, -y means x and y stays in the same spot, but you just change the sign for all of our numbers. Positive to negative, negative to positive. So K prime, L prime, M prime. K goes from 2, -1 to -2, +1. L goes from 4, -1 to -4, +1. And then M goes from 1 to -4, or from 1, -4 to -1, +4. So those are my new points. Now we're just going to go through and plot these. So K prime is at -2, 1. L prime is at -4, 1. And then M is going to be at -1, 4. So right there. So M, K, L. So if I go through and connect my vertices, I would end up with my triangle right there. And again, it's 90, 180, 270. So this ends up in the 180 degree rotation spot. If you wanted to use parchment or wax paper to check it, you could. But trust your process. This is a 180 degree rotation. And something I mentioned before, rotations are rigid, while the orientation, the way it faces, changes. It is still the same shape and the same size. Same for parts A and B. All right, so that is how you're going to go through and rotate figures in the coordinate plane. Again, this table is super vital for you to have either written down for reference, or you have it pulled up on your computer, whether through this video or on the completed notes. So that's up to you. But have this at the ready. All right, so like I said, I'm going to leave parts C and D for you to do. If you want to check to see how to do parts C and D, by all means take a look at my completed notes, and you will see some guidance there. All right, so with that said, we just have one example remaining, and it's going to be brief because if you're doing this on a video, likely you do not have a protractor at the ready, but I want to show you how we figure out the angle of rotation. So example 2 is going to ask us to find the angle of rotation and direction the rotation in the given figure. Point P is the center of the rotation. So, how we are going to go through and do this is as such. Alright, now, you just need to choose one set of points, okay? So, let me cover up part B so we're not looking at that. Okay, we just need to choose one set of points. Okay, so either you're going to do A to A prime, B to B prime, C to C prime, D to D prime. Now, we're not going to draw a line from A to A prime, but we're going to draw a line from the point in its prime to the point P. So I'm going to use point A in its prime, A prime, for this problem. So then I connect a line from A prime to P, and then I'm going to connect a line from A to P, like that. So I have now gone through and formed an angle from my prime in its original point to the point P. To figure out the angle of rotation is you would just use a protractor like we did back in section 1-2 to go through and figure out the angle. And if we kind of look at this, it is approximately, so I have my point on the vertex, it's lined up on the line, and this is going to cross through 80 degrees. So my angle measure for this is 80 degrees. Now, you would go through and do that for parts B and C. I'll leave that for you if you really want practice. If you want more guidance on how to do those ones or help with it, please just let me know the next time you see it if you have any questions. Okay, but all you have to do, and I'll start with B, okay, just choose one of the points. Doesn't matter if you choose N or K, L, or M. Let's just go with the N points. So I draw a point from N prime to point P, and then I'm going to draw a line from N to P. Just like that. Then you have your angle. All you have to do is take a protractor and measure it. So that is how you go through and find the angle of rotation. It's not going to be something that's a huge emphasis. It's just a way to show you how that's done and how to find it out. Truly, most of your time is going to be spent like example 1, where you're going to use the rules for rotation, use these coordinate notation, kind of plug in your points, find your new points, and then plot them and you have your rotation. So again, this table is super vital and super helpful. Alright, so that is it for section 2.3 on rotations. There's really not too much to dig into or worry about. As long as you have this table at the ready and know how to use this and plug in the points and get your new points, you should be good to go. So with that said, as always, you can take a look at my completed notes or ask me for some guidance next time you see me. Otherwise, that is it for section 2.3. Thank you for listening, and I hope you guys have a great day. All right, bye.